Okay, we continue with backend development stuff. So, okay. Last time we spoke about overall structure of an application. Usually we talk about web application because all these requests and responses are going through the web. Um, so, uh, Today we will dive into this part, databases. We will install a database which is called PostgreSQL or PostgreSQL. And we will learn some SQL. And today's lecture will be all about this part. We will not touch to this part. And we will touch to this part next lecture on Saturday. So last time when we spoke about these databases, I told you that there are some built-in app like software that you buy or you download, whatever, depending on it's free or paid. Okay, we talked about some of them like Microsoft SQL Server, for example, SQL Server. We talked about Oracle SQL database. And there are a lot of databases that are paid. Of course, there are also free ones that we are going to use this during this lecture. For the purpose of this lecture, we will use PostgreSQL. By the way, the pronunciation of this SQL is like a debate topic. Like some people say it SQL, the other people say SQL, the other people say SQL, but yeah, just pronounce it as you want. For today, we will download PostgreSQL. It is an application that will enable us to create a database, manage it, create some tables inside this database. But before, let's look at some terminology. So when we download a database software, be it Oracle database, Microsoft database, or Postgre database, we first install it, then we run it. Okay. When we run our application, there is a server that is running. We call it a database server. Okay. This is a database server that is listening for some requests and is listening to some port number. Okay. Whenever you want to make a request to it, you need to send a network request. It is not HTTP request, but they have their own protocols, but they communicate over TCP protocol. So there will be a database server that is running on our computer. Whenever like we develop application for public, there will be a database server that is running on some server on cloud, I don't know, on whatever. Okay. So inside this database server, we might have several databases. For example, let's say this is my company. Inside my company, I only have one database server that is up and running, waiting for connections. And I have several applications. I have HR application, for example, where I store my employees. Inside this, I will have like HR application. This is the database for my HR application, for example. And then I will have, I don't know, some task management application, let's say tasks management application. So inside one database server, we might have like multiple databases. Okay. And each database is for different web application. Okay. For example, last time we wrote a to-do backend for a to-do application. It might have a database called to-do app, for example, which is inside in single database server. Inside a database, there are a lot of stuff, but this single database, there are a lot of stuff, but the main entity inside a database that we are going to talk about is a table. Whenever we store an information about some entity, for example, a user, I don't know, order, product, we store it inside a table, just regular table, in any table you want, so inside the database, we will have a lot of tables. For example, if I'm if I'm creating an HR application, I will have database which is called HR app, let's say. Inside this HR app database, I will have some tables, for example, employees table, and I don't know, I will have vacations table where I store my vacations for each employee. And as you might guess, there should be some relations between these two entities, right? And because you need to know which employee takes which vacation. I don't know, is he allowed to take vacation? And then let's say we have some salaries table where we store each employee's salaries. And inside each employee, actually, there might be some relationship with their, like within this table, there might be some relationship. For example, one employee is superior to another employee, and etc. Okay, so this is it. We will talk about these tables. Whenever you create a database, for example, let's say I am planning to build a startup. I need to first design my database. At least visually, I need to see what entities I'm going to store inside my database and what is the relationship between those entities. For this, I will open some diagramming tool. Let's call diagrams.net. Diagrams.net. I think this Draw.io. This is a good drawing application. Create new diagram. Let's choose from here what we need to choose. Tables. Not this kind of table. I need some entity relationship diagram. Yeah, this I will choose this entity relationship diagram. We call it ERD, or entity relationship diagram. This basically is for designing a database. I will store this file on my desktop so that next time I can open and change it. Let's call it to-do app. I don't know. To-do app is good. Okay, to-do app ERD. To-do app entity relationship diagram. So, and they have created some tables here, like customers, orders, shipments. It makes sense. Where is my, sorry, I don't see anything. Sorry, I need to close this. I have a desktop application of the Draw.io. I will use it. Okay. What's happening? Is it updating? This was the right time to update. Maybe I could find something else. DB. Draw.io. Then open existing diagram to the app. Okay, that's enough. Need to close. Okay, so this is my entity relationship diagram. Later. So this is my entity relationship diagram. This is some template they have given us, but I don't have to use it. I will delete all of them. Let's say I'm designing a to-do application. Inside the to-do application, what will I have? I will have like list of to-dos. I need to store list of to-dos inside the to-dos table. So I will choose something from here. This, I will call it to-dos. Okay. So then we need to decide what properties a to-do might have. For the first, I will always have a ID of an entity. Like each entity should have an ID because you need some unique stuff to like determine what is. For example, let's say you have each of you have your own passports. Like you have your ID cards. You have some number on your ID card, which is called FIN, Ferdi İdentifikasyon Numarası, and it is unique to you. By using that number, I can identify is it you or someone else. So when we design a database, when we design an entity, we always give them an ID, and this ID is always unique. Then we should have some other properties. For example, to-do might have some property, let's say title of to-do, then is completed, let's say, is it completed or not? Or let's say what we might have, how do we add new is completed, let's create it at, let's say, well, at which time this to-do has been created. How can I add a new column here? Okay, is completed, created at, then we can have another column property which is called updated at, and then what? I need to okay. Just imagine that this is inside these lines, okay? So this is my to-do table where I will store my to-dos inside this list. This just defines an entity, and these are just properties of that entity. My entity is called to-do, and it has ID, title is completed or not, and created that, updated that, okay? Usually and for each of them, I need to have a data type. Like, is it integer? Is it string? Is it Boolean? Is it date, for example? For example, created at might be a date time. Okay, date time. Date time means that we will store date and the exact time this to-do is created at. Then we will have like date time for the updated at property, like both of them are date. Is completed should be something like Boolean, like, right? Bool, let's call it bool, which will be true or false. Title will be a string. ID maybe will be an integer. So this is our to-do, and this is properties of our to-do. Then I need to create a, let's say inside my application, I will have also users. I will have also users. For users, I need to create another table. So I will create a table, I will call it users. And by the way, whenever you name a table, you name it using this plural form, okay? We don't call it user, but we call it users. Not to do, but to do's. User will also have an ID, which is an integer. And then user will have, like, let's say full name, which will be a string. Then it will have, I don't know, email, it will also be string. Okay, this was a good way to copy it. Duplicate. Yeah, I'm gonna move to, okay. User have email, then user will have, let's say, password, then user will have like, we need to know when this user is registered at our system. Let's say it will have created app at point, so then it will have an updated at, then let's call it date time, because we will store date and time here. And then Actually, this is enough for now, I think. Yeah. So a user should have ID, full name, email, password created and updated that. Then to do will have the same stuff. ID title is completed. So what is the relationship between this user and a to do? Can if we say it with a just regular English sentence, user might have several to dos, and a to do will belong to a user. So this is the relationship, and this is how we define the relationship. And when we design a database like this, there are some relationships between these entities that might occur. So these relationships are called like this. For example, we will have one to one. Then we will have, I don't know, one to many, then many to one, then many to many. Okay. These are four relationships that can happen between those entities. For example, if we talk about, let's give an example to many. Let's say we are designing a course application, course database. We have students and we have courses. One course might have multiple students registered to the course, and one student might register multiple courses. So in this context, between students and between courses, there are many-to-many relationship. One-to-many relationship, this is an example of, this is an example of one-to-many, like one user will have many to-dos. Whenever we design a database diagram like this, we can show this using an arrow, not this arrow, but there should be some database entity relation. I should have used this stuff, but yeah. Which is many to many, one to many, for example. This is called one to many. How do I flip this? It's really hard to write this. I need one to many, not many to many, one to many. Maybe I can change their places. Okay. Okay. This sign here means that one user might have multiple to-dos. So this is how we design our database. Okay. I need to attach it somehow here. Okay. I need to attach it to here. Then okay. So this is how we design our databases. So we have users table and we have to-dos table. But when we look at to-dos table, we need to add another property to this to-dos. Okay. So let me show you why. Do we have a regular table here? Yeah, we have table. Well, let's say this is data of our to-dos. Okay. How can we add new columns to this table? Text, arrange to front to back. What do we have here? Edit, rounded. We should duplicate it, not like this. Okay, let's say this is our to-dos table, and inside our to-dos table, there are some stuff, okay? This is ID, then this is ID, this is ID, then we have some to-do, wash dishes. Let's drag them. Okay, and this is my to-dos table, then I don't know, make bed, I don't know, learn Python. Okay. Then what we have here, like we have ID, we have title, and we have completed, let's say, false, I don't know, false, true, let's say, and then let's find a way to duplicate it to the right. No, okay. I hope there was a way to add column to it. Row IO add column. Okay, this is the way. Okay, then we have what here? It's created on today. I don't know. Yesterday, I don't know. Last Sunday. Okay. So this is how we will store our data inside our table. Like we have ID, we have title, we have completed or not. Then we have like created at. I don't want to write all of them. But when we see this data inside our table, actually I need to learn, I need to know uh, to which user this to-do belongs to. Okay, this first to-do, wash dishes. To which user this to-do belongs. For that, actually, let's also define our users table. Like whenever I create my users table, I will have some data here. Let's add some columns. User have an ID like 1, like this, 4, I don't know, 5, 11, like some IDs. And they have what, Murat, Rasul, sen adın neydi? Maksud. Maksud ki sen grupta da Maksud var idi. Yoksa ben karıştırdım. Okay. Okay. Then users had some email, let's say a@b.com, b@c.com, I don't know, d@f.com, whatever. Then they have some passwords. Okay. Then what user had? I don't know. Yeah. So this is today. Salam. Today. I don't know. Today. So these are our users. These are our users, and these are our to-dos. Like this is the relationship between our entities, and this defines our entities. I'm just showing these two tables to show you visually what data we will store inside those tables. So I need to show to which user, for example, this to-do belongs to. I can add I don't know, add another column here saying that this belongs to, I don't know, Murat. This belongs to Rasul. This belongs to Maksud, let's say. But instead of using their names, for example, you might have two people named Murat. Instead of using their names, we need to use a property which will be unique, which is their ID. Like each entity will have unique ID. So instead of using Murat, we will use, like, let's say 4. Instead of Maksud, we will use 12. Instead of Rasul, we will use 5. So whenever, like, I want to see to which to which user does this to-do belong, I see that user ID is 5, and I go to this table, I find the user with ID 5. Okay. So when we create our to-dos table, we need also to add user ID, which will be an integer. Okay. Okay. Actually, this user ID, what happened? User ID. Okay, so this is our user ID. This user ID is what defines relationship between this entity and this entity. Whenever we want to define a relationship between, like one-to-many relationship, usually whatever we have here will have ID from this entity. If we have one-to-many from left to right. For today, we will create those tables. We will insert some data inside those tables, and we will try to select some stuff. I don't know. So I hope you have like general idea what we are going to store and what's the relationship between those two data tables. As we've already talked, we are going to use PostgreSQL database. So I'm going to download it. I haven't downloaded it, so you can also go ahead and download along with me because I don't have it installed on my computer. So for downloading, there are some installers for Windows, macOS. I will use macOS, of course. Postgres app. Yes, it says that I can use my terminal or I can download Postgres app if I'm using macOS. For Windows, you will probably have some installer that you need to download the installer. Okay. Since I'm using macOS, I will use Homebrew to install it through my terminal. I will open my terminal and I will install PostgreSQL. So while it's installing, let's see how we need to run it. PostgreSQL run. It's still downloading, starting the database server. They have their own documentation. So whenever we start our server, we need to run this stuff. It just starts the Postgres server, like it will start listening to our connections. And this means that this directory is like where you need to store the data of this database. Okay, as soon as it's installed, and one more thing we will need, we need a user interface to see the database tables and stuff. For that, we will use a tool which is called pgadmin. I don't know if I have installed pgadmin. I don't have it yet. So I will download the pgadmin. Where is it? Download for macOS, the latest version, pgadmin. Let's download it. Have some 5 minutes. Let's wait for it. You can also go ahead to download if you want, if you are interested. Else you can do it at home. For me, it's already downloaded. So let's clear the terminal. And I will use their command, like Postgres D and stuff. Postgres is not found. Why? Why it isn't found? I need to. If I run PostgreSQL, Postmaster become multi-threaded. What the hell is going on? Run init the one post. Bence ha. Contact directory. Aha. Fərqi yoxdur məncə. Amma elə şey yaz yadında qalsın. Okay. So after installing PostgreSQL and pgadmin, whenever you open pgadmin, you can connect to your running PostgreSQL database. as you see on the left side, I have PostgreSQL 15, and inside this, we might have several databases. We have one default database, which is called Postgres. But I can create a database inside my Postgres server. So I click create database, and I will name it to-do app. And I don't have any comments actually. Save it. So we have a new database which is called to-do app. Okay. So inside this to-do app, I need to create those tables. So we had two tables here, users and to-dos. I need to create those tables. So for that, I will click here and I will open query tool. We will write some queries. Whenever we interact with relational databases, most of the time we will use a language which is called SQL, which stands for Structured Query Language. Okay. We will use this language to create tables, insert some data to that tables, and I don't know, delete table, I don't know, like a lot of things. A lot of, like most of the things, actually all of the things inside this database, we will use this structured query language to do some operations. It is actually easier than Python, but let's first create our table. In order to create tables, we actually need to tell PostgreSQL that we want to create a table, just like this, create table. SQL is not case sensitive, so it doesn't matter if you write create table or create table or users, doesn't really matter. But the good convention is to write like keywords should be uppercase and my own words should be lowercase. This is a convention. You don't have to follow it, but it looks nice when you do it. So I call create table users. So I want to say that I create a table which is called users. And inside this brackets, I will have some of these columns, okay? Properties. So my users should have an ID. So I call an ID, which will be integer, and it will be a primary key. Okay. Primary key means that this is the, I don't know how to say it, just the major key of my, like major property of a user, and it will always be unique. Primary key cannot be duplicated. For example, two people can have the same name, but they cannot have the same ID. So primary key means it's the main key of my user that I am going to identify my user using this ID. You can also write it inside this backticks, doesn't matter. Like this property names can be written inside backticks or can be written without backticks, just like strings, okay? So then we will have a full name, and then full name will be a string. Well, when you go to let's go to Postgres data types, like in Python we had some data types like Boolean, integer, string, etc. In Postgres we will also have some data types, but they're actually similar, but the names are different. Okay. So for character types we use char, varchar, and text. For example, text is used for like long texts. For example, someone is going to write some description or blog, to use text type. Or if you want to limit some stuff, then you will use varchar. For example, I can limit that my full name cannot be longer than 30 characters. Okay, I can say it like varchar 30. I can also add a constraint which is called not null. This means that this field will never be empty. So a user, when you create a user, it should have a name. It cannot be null, like it cannot be empty. In Python, you remember the word none. It is like the same in Postgres, null. Then we have what here? Then we have email, password, and created at. Then we have email, which will also be varchar. Let's say it will be, I don't know, 50 characters, not null, and unique. Unique is just, as you know, as you might guess, it means emails will also be unique. Two people cannot register with the same email. Password also will be varchar, something like 100 characters. I don't know. Let's call it actually full of characters. Then we will have created at, we call it date time. I think I used the correct data type. Let's look at here again. For date, like we have date, we have time, we have timestamp, we have interval. Let's go to timestamp. This default value. Temporal. Date time. Okay, let's use timestamp. Timestamp is just timestamp, current time. Okay, timestamp, but as a number. Timestamp is current date and time, but as a number. For example, they usually calculate it through 1970 January 1. It's called POSIX start date. POSIX start date. It is 1970 January 1. Timestamp is a number of milliseconds. No, actually, number of seconds passed since this time. Okay. This is just a time represented as a number. Okay, I can add a default value here, which means that whenever I create a new user, created at will be now, like the exact time this user has been created. Then I will have updated at timestamp, and it doesn't have to have a value, and it can be null, because let's say if a user hasn't updated their own information, then they won't have updated that time. It can be null. Let's call it default null. So default value will be null. I don't have to insert the value to this. So I need to run this query. I will select this query and we'll run it. And it says that, so I have some error here. Is it? Okay, let's use not backticks, but regular quotes. It should work. ID. Onda skip hele de onda şey burada evde göster. Okay. Okay, actually, I needed to remove this quotes from these columns. Whenever I remove these quotes, I was able to run this query, and this query returned me a successful result because this table is created. Because I now have this table, I can actually, as far as I know, I can look at this table here. Let's look at schemas. Then we have inside schemas, I have public schema. Inside public schema, I have a table. Inside tables, I have a users table. As you see, the users table and users table have some columns: ID, full name, email, password, create and update that. I can actually use a, let's comment it. Commenting is like dash dash on each line. I can use a query which is called select everything from users table. I want to see what's inside users table, and I see that I don't have anything. I have the like ID, full name, email, but I don't have an entry inside my users table. So what if I run this? I run this query again. If I run this query again, it will say me that users table already exists. If I want to run this again, I can like add it here if not exists. Like it will check if this table exists. It will not try to create it. But if table doesn't exist, it will create it. Okay, already exists. Skipping create table. It's not a error, but it says query returned successful result. So let's create our second table, which is called to-dos. I will create a copy actually this stuff, and I will call it to-dos. ID will be integer, it will be primary key, full name, no, to-do have a title, which will be, yes, we will string, varchar, then we will have is completed. Now let's see if we have Boolean type inside Postgres, Boolean type, Boolean column. They should have Boolean as far as I know. Like is completed will be Boolean, and default value will be false. Okay. Why the internet is slow? So then we will have created that, updated that. Then we will have a user ID. Okay. This to do needs to have a user ID. User ID, and user ID should be an integer, because inside this user table, user's ID is integer, and I want to tell this database that this user ID is the exact user ID inside this table. For example, this shouldn't be some random ID. This should be some ID inside this table. For that reason, I will add something like references like users ID. Okay, it means that this user ID is ID of this user's column. I need to add foreign key. Yeah, something like this. Let's actually remove it from here and add it here. Reference foreign key is user ID. Foreign key means that it is a key, but not inside this table. Okay, it's some other belongs to some other table, and references users ID. Okay, something like this, and I can run this query. What happened? Yeah, okay, I don't need this semicolons. I can run this query, it will be successful. Whenever I look at my tables, I will see that. How do I refresh it? Okay, refresh. I have two tables, to-dos and users. To-dos table have some column, user ID. For example, if we look at constraints, we will have to-dos user ID foreign key, which means that user IDs belongs to other tables. Okay, let's just have a little bit break, then we will have we will look at how to insert and remove some data from those tables. Let's insert some data inside our tables, okay? So we have two tables, one users and one to-dos table. I need to copy this data to my, let's call it database SQL. I will copy them so that we have them inside. We don't forget, okay? So I will remove them from here. So whenever I want to insert some data inside my table, I need to actually call the keyword like insert, okay? Insert into table name. What's my table name? For example, I need to insert users, okay? Insert into users. For users, I will add ID, full name, and email, and password. ID, full name, email, password. Created and updated, that will be created automatically. Okay, so ID, full name, email, password. And what values I will insert there? Like ID, let's say it's 1. Full name will be, let's start, Murad. What was your? Eyvazov. Eyvazov. Your email was, let's call it a@b.com. Password is Murad Birchüstü. Actually, when I run this query, query returned successfully, so we insert it. We will see the result later. Let's continue inserting. I can also insert multiple instances. Let's call it like this. Okay, like values, first row, second row. Then what was your name? Rasul Canan neydi? Surname Arzumanlı olsun b.com Arzuman. By the way, Bahar. Sonra kim var idi bizdə? Maksud Qasımov c@a.com Maksud 5, 2, 3, 4. So we have inserted. What's happening here? What is email? What has happened? Has more target columns than expressions. Maybe something like this. Okay, so we have inserted 3 persons, 3 users inside our users table. Whenever I want to see what's inside my table, I will, actually there is one way I think I can like right click here and look at something. I don't know, if I double click, doesn't show me double click. I can, actually there isn't any way. Okay, let's just write our query. Like select everything from users. It means I want to see user ID, full name, I don't know, password. I want to see everything. It just start inside users table. When I run this query, it will show me the list of these users. For example, what we have here, like I have this created at, each of them have different time. For example, Murat has been created at 20:33, but the other guys were created at 20:35. And updated at times are null, password is this, email is this, full name is this, and IDs are those. I can say, for example, I only want full name and email, just like this, and I will see only full name and email. And let's insert some data inside to-dos table as well. Let's go insert into to-dos. What columns we had? ID title is completed, user ID. Okay, so I will have ID title is completed and user ID. values will be like ID will be, let's say, 1. Title will be make your bed. And then what else is completed? False. Actually, we don't need to add is completed because we say that is completed will be false by default. I will add user ID. Just user ID, let's say this is 1. Let's actually see our users. Okay, so make your bed will be for Maksud. And then buy a car will be for Murat. Then go to Germany and never come back will be for Chana. What else? I think this should be enough. And since we have relationship like one-to-many, I can have 2 tasks for 1 user, right? For example, let's add 2 tasks for Maksud. Okay. Remember, IDs should be unique, but this user IDs might be repeated. Learn Python, I don't know. And then let's add another one. Fifth to do, it will be, I don't know, what? Go to gym. Go to gym, go to kickboxing. It will be for Murat. As you see, your ID is 1, I put here is 1. And then what else? Pray is also for Maksud maybe. Well, we don't have Rasul inserted, let's say it's for Maksud. No, Maksud. Okay, I will run it. So we have errors. We don't, because I forgot comma there. So, okay, value too long for type character varying 30. Okay, go to Germany. Because when we created the table, I thought that the title should be no longer than 30 characters. My bad. Okay, it's successful now. Whenever I want to select, let's say select everything from to-dos table. So we have like how many to-dos? 6. Yeah, we have 6 to-dos here. So we have 6 to-dos like and 3 users. Okay. Actually, we can do some interesting stuff here. Yeah, let's say one challenge here is that let's first, before selecting, let's just update some data because we want to also update. Yeah, let's say I want to update this learn Python to false to be true. Okay. Sorry. Not like that. Okay. This to do with ID, I need to update it to be true. I will write update to do's set is completed to be true where user I mean ID is 2. Okay, it means that when you find a to do with ID 2, set is completed to true, and it means just we gave it the table name. Okay. Okay, it worked. Let's select. Now we have one to do is updated to true. It's completed. And then we have, let's update this one as well, because Murat is already going to kickboxing. So we have two completed to-dos, and all the rest of them are not completed, let's say. I can also delete some rows since I've already inserted some data. I don't want to delete them, but if you want to delete some data, you will write like delete from users. It means delete whatever inside the users. But I can also say delete from users where user ID is 1. It means that delete only user which has ID 1. I can also add ID is greater than 1. It means leave ID 1 but delete the whatever greater than 1. So I want to focus on actually selecting some data. Whenever I select some data from to-dos, let's say I select ID, and let's say I select title from to-dos. I want to see only to-dos that are completed. I need to write some condition. When I write some condition, I will write where. Select title from to-dos, where is completed equals true. Okay, true. I can actually write some other stuff. Maybe for example, I can write and, just like in Python, we have and or not. For example, is completed true and ID is, I don't know, 2, let's say. And it will show me only 1 because I only have 1 completed to do which has ID 2. Of course, this query doesn't make sense, but yeah. Okay. One interesting thing I want to note here, let's get also user ID. Let's say, as you see, there is a challenge that I have user ID on this table, but I don't have user name. Whenever I want to, let's say I have to do app, I have released it, I have published it, and people are using it. I don't want to show my users ID of the user. I want to show them actual name of the user or email, I don't know. Then I need to join those two tables. Actually, joining is very simple. I will write something like this. For example, I select from to-dos and I join users to to-dos table, and they should have some intersection, right? In this case, intersection is user ID equals to user.id equals to to-dos.user ID. Like ID here equals to user ID here. The intersection is this. So I will write join users on users ID equals to-dos user ID. When I do this, actually nothing will change. Let's just run it. When I do this, I can actually select, instead of using user ID here, I can also show the user's full name, users.full name. It will be like something like this. Okay, we will have like Maksut Kasımov have make your bed. Maksut Kasımov has learn Python, and we can also add like is completed here to see that which user has completed which task. This is some kind of small report. Okay. When we talk about reports, actually, we can also talk about some aggregation operators. For example, I might want to count number of to-dos. Let's say select count ID from to-dos. It will just return me a single number saying that I have 6 to-dos. If I say like users, it will say that I have 3 users. One good condition will be here to select, let's say, I want to see how many to-dos each user have. Okay. For this, actually, I need to select from to-dos table. Okay, to-dos table. Whenever I do this, let's say I want to select user ID from to-dos. So we have like 3, 3, 3, 2, 1, 1. Okay. I can group them. Okay. And I can count, for example, this user 333 have 3 to-dos. Okay. That's why it's repeating 3 times. For example, Murad has 2 to-dos. That's why Murad's ID repeating 2 times. And Canan has only 1 to-do. That's why he has only 1 ID here. I can group them by user ID. Okay. Group, there is one clause which is called group by user ID. Okay. Then it will have only one group. They won't have duplicates. Then I can have like count ID. It will show me like this user has 3 to-dos, this user has 1 to-do, this user has 2 to-dos. But as you see, we don't want to see user ID here. I want to see user full name. That's why I can also join users on users ID equals to-dos user ID. Then what else do we have here? Like instead of user ID, I will show users.id. No, full name. Then I will see what's the problem here. Yeah, to-dos.id. What's happening here must appear in the group by clause. Okay, users.full name. Okay, so I group them by full name, and each name I count how many to-dos they have. Something like Maksud has 3 to-dos, Canan has 1 to-dos, Murat has 3 to-dos. Like I'm kind of compressing all the topics together. Like you don't need to be expert at this, but I'm just showing that a lot of stuff you can do with SQL. For example, I can order the rows, order by, for example, full name, order by full name. For example, let's see. When we order, they will be in descending order. The ascending order from K to M. I can also write here this. It will be the reverse order from bigger to lower. I can order by, for example, count. I can order by the count. Example, I can see which user has most to-dos, for example, descending order. When I see ascending order, I will see the in the first row, I will have the user with lowest number of to-dos. I can add another conditions. I don't know where, for example, where is completed is true, for example. Then we will have something like Maksud has 1 completed to do, Murat has 1 completed to do. I think I can also write it here after group by, like having, no, I will not be able to do that. Is completed true. Okay. Yeah, basically, the select statements actually can be very, very complicated. The easiest thing to write in SQL is select. Because of this case, this is excluded from to-dos. I can actually change this. Let's SQL left join meme. Okay. You see this meme? You see this meme? This guy has hair and beard. For example, when you call left join, actually this is not right. Let's say we have two tables, right? We have users and to-dos. When I join those two tables, let's say I want all data from this table, but I want some nulls from this table, and there might be some differences. For example, if I want data from both of those tables, I need to do full join. It means full join. It has beard and it has hair. If I want right join, for example, it will have like only hair. It's like when you look at this in reverse order. If I want left join, it will be bold, but it will have the beard. You get the idea. For example, here on this example, I want to see Canan, but I want to see 0 on the right side. So using this, I will write right join. Right join means that this is left, this is right, right? Let's move it to the same line. This is left, this is right. This means that I will select all users. I will show all users here, but some to-dos might be 0. Let's actually see. For some reason, we didn't. For some reason, we didn't see to-dos. How can I do this? Actually, this is not related to it. Let's add new user. I need to show it. Okay. Insert into users. Insert into users ID, full name, email, password, values is what's the values here? For Orhan Hüseyinli, email at email.com. Okay, let me just enter new user. This user won't have any task. Now I will remove it. Let's run this again. Let's remove this case for now. Okay, some reason. Okay, right now. Now, for example, I created a new user which doesn't has a task. If I use left join here, it will show all of the data from to-dos table, but it will skip some users table. But if I do right join here, it will show me all of the users. Right means that all of the users table will be present, but this count will be 0 because Orhan doesn't have any tasks inside to-dos table. Okay, so this is actually right join. There should be a full outer join. Let's see how this works actually. In this case, it will not make any change. Right join, okay. Yes, so what else I can do here? This count is called aggregate operator. It means, for example, I start counting number of to-dos. Like there are also some other stuff. For example, I can do AVG, which stands for average. I can just show average number of to-dos for some reason. This is the average number of to-dos. For Orhan, it's null. Usually, like it doesn't make sense here, but for example, let's say you have some employees and you have some salaries, then you want to know average salary in the company, then you will do like employees dot salary. Okay. Actually, I should have some good data inside git gist.github.com. Let me see. I should have a lot of data inside my profile. Your gists. This is not. I don't think. domains deep equals keybase proof use fetch Instagram SQL. Yeah, let's copy this. Okay. Let's actually remove these to-dos and users. I want to show you some. How can I drop this table? Delete, drop, yes. Delete and drop, yes. Okay. So I copied some long queries from my old code. There are a lot of data here. Let's see actually. Let's select, let me refresh it. I have 3 tables, users, products, and orders. Select everything from users. So we have a lot of users, like 50 users. Then we have products. We have like 100 products. Then we have orders. Then we have, order is like, you see, in order table, we have user ID, product ID, and is it paid or not? Let's see, for example, number of orders for each user. For this, I will select from orders. Like let's select user ID and count count product ID maybe, and we will join like write join users on like users.id equals to orders.user ID and group by what? Group by user ID. I can see like each user has how many orders. Then what will I do here? I can also use like instead of users ID, I can use users dot what users have here? First name and last name. Users dot first name. I will group by first name. Yeah, for example, this is how many of them have how many orders. Then well, let's see actually product. We have product price. For example, let's select from products. Let's see, select everything from products. Okay, what's the ulduz? Select everything from products. Let's say, for example, select average price from products. Average price is this. I can also write select max price from products. Like this is the max price. And I don't know, mean price from the products. This is one for one USD. There is something. I can also join with products maybe on products on products.id equals orders product ID. Then I can write some products price. Products price. Let's see if this works. I don't know. Yeah, it works. For example, Neha has made 8 orders and it totals to, I found some of prices of products that they have ordered. It's like I can let's order by actually then order by some of the products in descending order. Descending, we will have the max on the top. Okay. So this is Duan. Duane is actually the person who ordered the most products. Like the maybe we can select him and I don't know, we can offer them some good coupon code, whatever else. So this query, yes, there might be a lot of like complicated queries than that, but I just wanted to show you just how complex it can get. This is actually not very complex, but there might be a SQL select statement, which is, I don't know, 100 lines long. For home, I will try to send you a video to learn some of these basic statements, and then you're not supposed to be expert at it, but at least I recommend you can go over some queries and you can write some of them. I will try to send you a website where you can write some queries without just without installing anything on your computer. There is some website, but I don't remember the name, but I will find and send you, and you can just do some exercises. I think that's it for today. Do you have any questions? Is there any videos? I don't know how to fix that issue, but maybe just skip it for now. I will send you I'll try to find the website where you can write SQL queries just for free. I will uninstall it. Yes, it's also an option. Yes. Well, so when we actually, you see, we have a database server running here. Actually, when we write our backend, let's say my backend receives an HTTP request, and this backend will create an SQL query, and it will send it to database. Database will do something with that query, will send a response, and backend will send the response to the front end. Okay. So last time when we wrote our API here, our database was this array, this list. But next lecture, instead of this list, we will use our database. For example, instead of inserting it like this, I will write here, I don't know, insert into to-dos, something like this. And it will go connect our database, insert it, and select it, and etc. Actually, yes, that's it for today. If you have any questions, let's discuss. If you don't, let's continue going on. So the next section, starting just no, next lecture, we will see writing SQL queries from Python, inside Python. And next Tuesday, we will start learning HTML.